Welcome back to The Explainer. We have an absolutely fascinating set of data to unpack today. If you look at the landscape of artificial intelligence right now, we're living in this crazy micro-macro paradox. On one hand, we're tracking $100 billion infrastructure projects and gigawatt-scale power demands. That's the macro. But on the other hand, we're seeing massive, landscape-altering performance shifts dictated by literal microscopic software configurations and API toggles, the micro. Today, we're going to bridge that gap. We're going to look at the staggering physical realities of AI and then zoom all the way in to give you a detailed instruction on how to actually apply new API settings to unlock cutting-edge model performance.
Okay, let's dive into this agenda. First, massive AI infrastructure spins. Second, applying OpenAI's API settings. Third, watermarking limits and security flaws. And fourth, AI materials and compute costs.
Starting right off with Section 1, massive AI infrastructure spends.
To really understand the software, we first have to wrap our heads around the staggering physical and financial scale of the hardware it runs on. 1.2 gigawatts. Think about that for a second. This isn't a theoretical projection. This is the initial power requirement for a massive new AI campus being built by Brookfield and NextEra. And get this, they're building it at a former Department of Energy site in Kentucky. We're talking about a roughly $100 billion project paired with 2 gigawatts of new gas generation and 2.6 gigawatts of battery storage. And that 1.2 gigawatts, that is literally just the start. They're planning to scale it up to 1.8 gigawatts by 2032. The physical footprint needed to sustain our AI ecosystem is just blowing up.
And when we look at the financials, Big Tech's recent Q2 earnings completely validate this physical expansion. Microsoft just posted $90 billion in quarterly revenue, up 18% year over year, with Azure crossing the $100 billion mark for the full fiscal year for the first time ever. But look at Meta, $60.8 billion in revenue, which is great, but the truly jaw-dropping figure here is their capital expenditure. They just raised their 2026 AI CapEx floor to $130 billion. $130 billion! And this absolute hunger for hardware is flowing right down the supply chain. ARM hit record Q1 revenue, noting that AGI CPU demand has doubled to over $2 billion.
However, playing at the scale means managing massive, shifting portfolios. Look at this really striking split in Microsoft's portfolio for Q4. They actually booked a $3.2 billion gain on their stake in Anthropic. But meanwhile, their stake in OpenAI was marked down by $600 million for the quarter. Now, to be perfectly fair and view this impartially, OpenAI's position still delivered a massive $5 billion for Microsoft's full fiscal year. But it just goes to show that even the absolute biggest players are dealing with some dynamic fluctuations when it comes to valuing these frontier AI labs.
Let's move to and see how this builds. Section 2, applying OpenAI's API settings. So let's shift from the macro financials of these giant data centers right down to the micro-level configurations you need to actually unlock real model power. The key takeaway I want you to grasp here is that headline benchmark numbers are increasingly configuration dependent. It used to be that you could just look at a raw model's output to judge how smart it was. But today, raw models alone don't guarantee top performance. It's all about having the precise settings applied under the hood. So how do we actually harness this? I want to give you a detailed instruction right now based on OpenAI's latest revelations regarding GPT 5.6 Sol. To squeeze out maximum reasoning capability, developers need to follow 3 very specific steps. Step 1. You absolutely must route the model via OpenAI's Responses API rather than the standard endpoints. Step 2. Explicitly enable a feature called retained reasoning. What this does is preserve the model's chain of thought between different steps of a complex problem instead of just flushing its logic cache every time. Step 3. Enable compaction. Instead of hitting a context window limit and just aggressively chopping off your earliest kata, compaction forces the model to dynamically summarize its context as it goes. Configuring these settings literally rewires how the AI processes information.
And this brilliantly illustrates the impact of those exact instructions. Look at the measurements. When GPT 5.6 Sol was run under the official ARC AGI-3 benchmark harness, just right out of the box, it scored a mere 7.8%. Meanwhile, Claude Opus 5 was sitting at a very strong 30.2%. But when developers applied the exact settings we just covered, routing through the Responses API, enabling retained reasoning, and turning on compaction, GPT 5.6 Sol score exploded to 38.3%, easily edging past Opus 5. This is exactly why knowing how to configure your AI is just as important as the model you choose.
And to completely validate this instruction, we have a quote from ARC Prize co-founder Francois Chalet. He confirmed, "These settings are legitimate general-purpose API features, not a custom benchmark harness. So this isn't some clever parlor trick just for the lab. These are real, applicable developer tools that you can use right now in your own stacks to boost performance.
Moving on to Section 3, watermarking limits and security flaws.
Because look, as these models get incredibly powerful and perfectly configured, the friction points in cybersecurity and content provenance become glaringly obvious. Let's look at watermarking first. Ars Technica recently did a hands-on test of Google's SynthID watermark, and the results are pretty telling. Inside Google's own internal generation pipeline, the watermark holds up really well, but in the external web reality, it was trivially bypassed. I mean, users could simply run it through non-SynthID models, or just regenerate the content through another tool to strip the label entirely. It reinforces a harsh reality. Provenance labeling just cannot solve attribution at internet scale as long as unwatermarked tools are out there.
And the cyber reality check goes way deeper than just watermarks. Alibaba NLP just dropped SecRespond, the first benchmark for large language model agents doing post-compromise incident response. They tested 23 frontier models across 10 real-world cyber ranges. The result? Total failure to hunt. Not a single model fully detected and remediated an incident. The agents are fine at following alert-driven leads, but they fail entirely to proactively hunt for silent intrusions. Combine this with the newly disclosed roofroot flaw, which is a maximum severity CVSS 10.0 vulnerability in the open-source Rooflow AI agent platform that exposed 233 tools to unauthenticated remote code execution, and it becomes crystal clear. AI agents might be powerful, but right now they remain highly vulnerable and deeply reactive.
Finally, Section 4, AI materials and compute costs.
For this final segment, let's zoom back out. We've seen the micro configurations and the software flaws. Now we need to look at the impending macroeconomic compute crisis. The industry is pushing the physical layer to its absolute limits. Look at these developments. Cusp AI and NVIDIA just launched an AI materials foundry to discover novel compounds using physics simulation-trained foundation models. And what's really incredible here is their advisory board. It features both Geoffrey Hinton and Jan LeCun. That is an unusually high-profile pairing, and it really underscores how critical new materials science is to the future of AI hardware. Meanwhile, the European Union has formally opened bidding for 7 AI gigafactories. 7! Each site is designed to host over 100,000 chips, which is roughly 4 times the current data center scale in the EU.
And just look at the mountain of cash required for that European initiative. The EU is targeting a massive €30 billion combined funding goal by mid-2027. They're putting up €10 billion in public funding and targeting another $20 billion in private investment to make this 4x scale a reality. The scramble for sovereign hardware capability is completely underway.
Now, what's really interesting about this slide is this grim warning from Dwarkesh Patel. He argues that AI compute could get 10 to 15 times more expensive as lab revenue growth outpaces the roughly 3x annual compute buildout. We are building infrastructure as fast as physically possible, and yet demand and revenue are growing so much faster that the economics of compute are on a direct collision course with scarcity.
And we're already seeing concrete evidence of this crunch today. Spot GPU prices are up more than 40% since February's trough. But here is a truly shocking data point to anchor Patel's warning. Google is reportedly paying SpaceX $900 million a month, yes, a month, for access to 110,000 GPUs. That is roughly twice the current spot pricing. When a massive tech giant like Google is paying double the market rate just to secure compute, you know for sure the hardware bottleneck is tightening violently.
So the crucial point is this. As hardware bottlenecks tighten and compute becomes exorbitantly expensive, will future AI breakthroughs rely entirely on optimizing those micro-configurations we discussed earlier? If we can't just throw 10 times more GPUs at a problem, mastering those API settings and reasoning workflows is going to be the only way forward. We will be tracking all of this right here, so please subscribe to AI Vanguard AI to stay at the cutting edge of industrial AI. If you found this synthesis valuable, please like, comment, and share. Let us know down below if you've tested out the new Responses API settings. Thanks for learning with us, and I'll see you in the next explainer.